Timothy and the man with no mouth.
Remote camera.
Good morning, everyone.
Can you hear me? Can you hear me? Please say yes if you can. Say no if you can't. Okay, thanks a lot, Jonah. Okay, got it. First, good morning and Happy New Year. I'm very sorry that I have to start the semester online. I hate it more than you do, believe me, but I had no choice. Um, I have to be home for 4 weeks, and hopefully after 4 weeks, I will be back with you. Um, Now, a lot of you knows me and a lot of you don't. So I have to start by basically introducing myself and going through the syllabus. Uh, First thing first, the only way we can make those 4 weeks successful is with you participating in class a lot and ask me questions and tell me that you don't see what I'm writing or you see what I'm writing and come to my office hours. That's the only way we can make those 4 weeks successful. After that, hopefully everything will be back to normal. So I'm gonna start first by going through the syllabus and introducing myself. All of you have the syllabus on Brightspace, but I will go through it with you. First, please, okay, one thing, please mute yourself and in mute if you want to ask a question or you want to answer. So we don't hear any background. I don't want to mute all of you by myself. You guys mute yourself. I only want to hear you when you want to answer the questions or ask a question. And use chat as much as you can because I can see it all the time. Okay. All right. So I go first through the syllabus and get it over with. So my name is Norma Elias. My office is in the CLO building 348. My number is right there, but don't call me because I don't answer my phone. My email, you have it, elias@pnw.edu. So please call me, email me whenever you have a question, and I'm usually good at answering your emails. And my office hours this semester are before class on Monday, Wednesday, after class on Tuesday, Thursday. Now the book, that's the book, that's the same book you use for 163. And the calculator, as my student knows, I don't use the calculator a lot, but you have to have it so to check yourself at home or to use it at home. So in class, I will not be using it much. The course content. Uh, Calculus 2 is different from Calculus 1 in the following. Calculus 1 mainly emphasized derivatives. So from the beginning to the end, we actually talked about derivative, basically. Calculus 2 is four different things. So it's a collage of four different ideas. The first part of the course will be about application to definite integral. So we introduced definite integral in Calculus 1. Calculus 2, okay, why do we need that? So we're going to use definite integral for basically finding areas, finding volumes, finding work, finding mass. So we'll have several applications to definite integral. That will be the first part of the course. The second part of the course will be the following 4 weeks. We will actually start learning the techniques of integration. We saw very, very little in 163, but in Calculus 2, we will learn all the techniques. So we're going to be spending like 3 weeks at least to study the techniques of integration. Part 3 of the course, which is usually the hardest part of the course, is what we call infinite series. So basically, we're going to understand, like if you see somebody writing 1 plus a half, plus a third, plus a fourth, plus a fifth, and they keep writing till infinity, plus, 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 plus. What does this infinite sum really actually mean? So we're going to give meaning to an infinite sum. And then we will extend something we did in Calculus 1. In Calculus 1, we saw that every function can be locally approximated by its tangent line. And that was the equation of the tangent line. So that's what we saw in Calculus 1. So every function locally look like its tangent line. In this class, actually, we're going to extend that a little bit And we're going to get a better approximation, and we're going to approximate every function by a polynomial. So we're going to see all functions as polynomial, and we're going to have a better approximation as we saw it. The last part of the course, which is the easiest part of the course actually, it's basically we go back to a little bit of pre-calculus. So we study conic section, parametric curve, and we'll throw in a little bit of calculus in the meantime. So these are the four parts that we will be working in this course. Now, the student learning outcome, I don't really read them because that's at the end of the semester. They will not make sense to you at this stage. Now, homework. I assign daily homework. I mean, every day, I give you a homework. Like tomorrow's homework is already on Brightspace. For those who don't know me, go to Brightspace. On the content page, there is a module called homework. Click on homework for 1 1425. You will see your homework for tomorrow. Now, your homework for tomorrow is not from the book, because the first few days I will be reviewing the material from 163 that I need for this course. So you have a worksheet and the homework is from the worksheet. So you don't really need the book for tomorrow. But I do not collect homework, but as you guys know by now that doing the homework is crucial. I mean, if you don't want to do your homework, just drop the course. There is no way out. I mean, only doing the homework will make you successful in this course. There is no way out. And as the way I handle the lecture is that at the beginning of the class, I answer all your questions within a certain limit. And then once I answer your question, I go back and start introducing new material. So if you do the homework, you get, and you can't do them, which is usually it's okay. I usually answer your questions. Now, quizzes. Okay. Every Friday, you guys will have a quiz, which should be the last 20 minutes of the lecture. And I don't give makeup quizzes. I do drop the lowest 2 quizzes. Now, for the first 3 weeks, because I will not be able to be with you, the quizzes are going to be online, meaning that I will put the quiz online at the end, like around 11:30 on Friday. You guys will have to take it at home. Once you take it, you're going to upload it into Brightspace. So the first 3 weeks only, the quizzes will be online. Now the exams. I give you 3 exams throughout the semester and then the final exam. The date of the exam are written here, and the way I do the exam is the way, for those of you who had me in 163, is the same idea that 163. So 1, 2, 3, the fourth is an exam. Again, 3 weeks, the fourth is an exam. 3 weeks, the fourth is an exam. And exam number 1 only will be taken at the testing center. And after that, I will be back in school and everything will be back to normal. So exam number 1 will be at the testing center, but quiz 1, 2, 3 will be taken online. And the last day to drop the course is April 11, and then the grade. So 20% are your weekly quizzes, attendance, and homework. And then 55% the exams and 25% your final exam. The grading scale is just, the regular grading scale. I will not read them. Brightspace, that's the only way I can communicate with you. So everything will be usually written on Brightspace. So it's your responsibility to check Brightspace every day. Now, attendance, I take the attendance regularly. Now I'm going to take it through Zoom, because Zoom keep track of the attendance. So I will use Zoom to take the attendance. After that, I will do the attendance in class. Lack of attendance will affect your grade at the end of the semester. Okay, so students who attend regularly will be usually looked favorably. It means if a student attends regularly and the student is a borderline student, I will help the student. If the student does not attend and he's a borderline student, the student will not get any help from me. Now, office hours. And this is crucial. I strongly encourage you to come to my office hours. And please do not wait till the end or before the exam to come. Just come, ask in the classroom. Bradley and Arthur are present for attendance. Okay. Okay, thanks. I will keep track with that. All right. I want to say something. All right. So, office hours. Please do not wait for the day before the exam to start studying for the exam. It does not work this way. Keep up day by day by day, and come to my office hours, which are on Zoom for the time being. But then later on, they will be in my office. Please use them. Come to my office. Ask questions. I can help you. I can help you. Don't wait for the last minute to catch up. It does not work this way. Okay. And there is also a tutoring club, and use it. There are some very good students at the tutoring club who can help you a lot. All right. So that's the syllabus. What else I will need to talk about? Now, book access. I know 2 students are having difficulty with the book access. Anybody else? Anybody's having difficulty accessing the book? Anyone?
Miss Elias,
Jonah, I cannot get it either. Anybody else?
Miss Elias, I have a question.
Go ahead.
Is it the same book from last semester?
It's the same book as last semester, yes.
I just
So who cannot access it? Jonah said cannot access it. Let's see. That's weird. Jonah, you have it from last semester. You cannot access it also? Because I just called the bookstore like 10 minutes ago, and they told me that Pearson should send you the access code by email. The access last semester expired. Okay. Guys, we used a link. I can only find the email from last semester. Do you need to visit the bookstore? When I called the bookstore, what they told me verbatim is that Pearson sent you the access code by email. That's what they told me. You can go back to the bookstore. I don't think it's a bad idea. Go to the bookstore and tell them that my professor called and you told me that I should get it, but I did not get it. So they will give you a link that you can call Pearson. Rocco, what do you have to say? Say it out loud.
Sorry, Professor Elias. I was saying that I have a PDF of it if anyone's having trouble with the textbook.
Okay.
Also, hi, Professor Elias. Good to see you.
Hi. All right. Okay, so what your classmate is saying that since I do not use my lab, it means I don't use online homework. If you guys want access to the book, you can email your classmate. And he will give you the PDF. I mean, he'll give you a link to a PDF for the book. This being said, for those who could not have access to the book, check your email. If you cannot find it in your email, the bookstore is supposed to send me an email telling me who you should contact in Pearson. What you guys can do is contact Pearson, use the customer service to contact Pearson and tell them what's really going on. Tell them that you cannot have access to the book and see how far we can go. Now for today and tomorrow, and for the first 3 days, you do not need the book because the homework is online. And keep me updated. Let's see how far we can go with that. All right, any other questions? Very good. So the first few days, I will review the material of 163 that I think is absolutely crucial for us in this course. So I will review integration, basic integration. I will review definite integral, and then I start later on chapter 6. So let's get started, and please answer questions, put them in chat if you don't want. So let's start. So let us recall a little bit what we did in 163. So we had a function f, okay? And in 163, we mainly emphasize differentiation. It means the derivative of f. And we call this differentiation. And this is called the derivative. Now, at the end of 163, we started building the way backward. It means we have the derivative. We have to find the original function. The process from going from the derivative to the function is called integration or anti-differentiation. Okay. Now, this function f, do you remember what do we call it? What did we call this function? Suppose we have the derivative. We're looking for the function knowing the derivative. What did we call that? You guys remember? Antiderivative. We call this antiderivative, or we call it indefinite integral. Okay, so in this semester, we're basically moving backwards. So we know the derivative and we have to move to the antiderivative. So let us remember very quickly the definition of the antiderivative. So review one, because that's how we're gonna start. Antiderivative or indefinite integral. So a function f is called an antiderivative of little f if when you differentiate it, you get f. So you have a little function f. F is an antiderivative if the derivative of f is little f. So example number one, find an antiderivative of f of x equal x squared. What do I mean? It means I want you to find a function. When you differentiate it, you get x squared. So if I go fast or you cannot write, you let me know. Okay, so don't shy away from anything at all. So let us find antiderivative of f of x equal x squared. So this is f of x is, we have to find f so that when we differentiate it, we get x squared. Okay, so quickly, because I know that most of you have seen this before. So what is the function? When we differentiate it, we get x squared. First, we have to remember what the derivative do. The derivative take a function, x to the n. What the derivative does, it brings down the exponent and then takes away 1 power. So anti-differentiation, it means if I have the x squared, it's gonna add the power. So that's the best candidate for it. But as we remember, is that derivative of x cubed is 3x squared. Now, to compensate for the 3 here, we divide it by 3. So f of x is 1/3 x cubed. Okay. So question number 2 is, give me another antiderivative of f of x equal x squared. So quickly, give me another antiderivative. So that's 1. Give me another one.
Didn't you do any of them like and then add a number like +2 or whatever?
Whatever. We take the same one and just add a constant to it. Okay, your classmate won't add 2, I will add 2 to it. Again, that's another antiderivative because when I take this function and differentiate it, we know very well that derivative of a constant, the function doesn't change. If it's a constant, the derivative is 0, and derivative of that is x squared. Okay, so this leads us to the first thing is that any functions, any function of the form 1 over 3 x cubed plus c, where c is a constant, is an antiderivative of x squared. Okay, because adding a constant will not affect the derivative. So let us recall graphically what's really going on. So graphically, suppose I drew 1 over, this is 1 over 3x cubed, one antiderivative. Okay. Now, who can explain graphically if I take, your classmates suggested 1/3 x cubed plus 2. Why do, so this is, let me call this F, and this call it G. Who can tell me graphically why those two functions have the same antiderivative, have the same derivative?
Because the slope of the line is the same.
Exactly. Antiderivative of f of x equal x squared. Why those have antiderivative? Because if I take any point here on this graph and I take the point on the graph, the derivative is the slope of the tangent line. The derivative is the slope of the tangent line. So since those are nothing more than a translate of each other, we have exactly the same slope. It means the same tangent, slope of the tangent line. We have the same tangent line. The slopes, sorry, we have different tangent line. The tangent lines are parallel. It means the slope is the same, the derivative is the same. So any function will have exactly the same derivative. So graphically, it makes sense that a function have the same derivative. And this leads me to the following theorem, which is really important. Tells me the following. Suppose we have two functions. You have a little function f. And two students found two different antiderivatives. So one student find an antiderivative f, another one find antiderivative g. So let us suppose f and g are two antiderivative of f on an interval. What does this mean? Is this possible? And the answer is yes, they are possible, but the two functions will be equal up to a constant. So if Joe found one derivative, Peter found another derivative, it's okay. The difference between them will be actually a constant. And this is going to come up with us in this course. A lot of time we will find integrals, antiderivative. Two students will have two different answers, but we should be able to reconcile them. It means we should be able to show that they are equal up to a constant. Okay. Now, indefinite integral. What is the indefinite integral? Indefinite integral is nothing more than the antiderivative. So it's like synonymous to antiderivative. So instead of saying antiderivative, we use the notation indefinite integral to say that. So indefinite integral or antiderivative. Okay, so we use the notation. That's the wiggly sign, which is just the s, which is being stretched, f of x dx, called indefinite integral to mean the antiderivative of f. So indefinite integral, and this notation, I will remind you where it comes from when we hit definite integral. So the indefinite integral is nothing more than the antiderivative of f. So indefinite integral of f of x dx is f of x plus c, where f prime is f. So it's nothing more than a notation for the antiderivative, and c is a constant. Now, for example, indefinite integral of x squared dx is nothing more than 1 over 3x cubed plus c, because the indefinite integral is the derivative of that. Any questions so far? Okay, so we're going to start now finding the rules of the antiderivative. So now let us find the following. The most important rule we're going to learn, we know, is the power rule for indefinite integral. Question number 1, what do I mean by that? First, let us remember, what does the integral of dx mean? Quickly, I want answers. When you see integral of dx, which is you will see a lot, what do we mean by that? Means what is the function that should sit in here when we write the integral of dx? What do they mean by that? Anyone? Anybody?
Can you repeat the question, please?
Yeah, integral of dx. It's weird. What do they mean by integral of dx? We talked about the integral of f of x dx, which is the antiderivative of f. So if I put nothing here, I mean, there is nothing called nothing. What do they mean by integral of dx? What is the function here? Yeah, dx means we integrate with respect to x. That's correct. But what function they are talking about here?
I mean, it says 1.
1, exactly. It means it's 1. So when you write integral of dx, it means the integral of 1 dx. That's the function they are talking about. So now what's the integral of 1 dx? It means what's the function whose derivative is 1? This is x plus c. Okay, so that's what they mean by integral of dx. There is a function, really. They don't write it. The function is 1. So this is x plus c. Now, the power rule. It means what's the antiderivative of x to the n dx? It means what is the function? So I'm looking for a function. When I differentiate it, I get x to the n. Okay, let us remember that. What is the function? When you differentiate it, you get x to the n. So let us remember what derivative will do. So we are basically reversing differentiation. So let us remember what the derivative does. The derivative, it's n takes away a power. So when I'm thinking about antiderivative, if I have x to the n here, this has to be 1 more. So when I differentiate, I get x to the n. But if I put xn plus 1 here, this is going to be n plus 1 times xn. So I have to divide by n plus 1 to be able to recapture xn. So the antiderivative of x to the n is going to be 1 over n plus 1 x to the n plus 1 plus c, as long as c is a constant. All right. This is good. But when does this formula give us problem? Back to you guys. Under what condition this rule works?
Isn't it's a problem when it's like x to the negative 1 power?
Right, it means n is what? It means n is what?
0?
No, if n is 0, I don't have any problem. Because if n is 0, x to the 0 is 1. I'm back here. That's not an issue. Which value of n gives me issue here? Whenever you see a denominator, something should pop up to your mind. Right, n has to be different from -1. Because if n equal -1, this would be nonsense. I will have 1 over -1 plus 1, which is a 0. So the power rule holds as long as your n different from -1. So now the question is, what happens when n is equal to -1? It means x to the -1 dx, or the integral of 1 over x dx is quickly. What's the antiderivative of 1 over x? That's the ln of the absolute value of x plus c. Okay? All right, so let me summarize the power rule together. So the power rule are, and which is absolutely integral of x to the n dx is 1 over n plus 1, x to the n plus 1 plus c, when n is different from minus 1. And when n is 1, is ln of the absolute value of x, not x absolute value, because ln doesn't make sense for x negative and we need the absolute value. So let us take 2 problems to practice that. So example. So whenever I do example, I want you guys to do them in front of you just to make sure you can do them. So I start obviously with a trivial one. Antiderivative of x to the 5 dx. This is equal to, okay? In this scenario, n is equal to 5. So it's 1 over 6 x to the 6 plus c. Example number 2. What's the antiderivative of 1 over x squared dx? Quickly. How do you rewrite that? Just say
X to the negative 2.
what?
X to the negative 2.
X to the negative 2, that has to be my starting point. And then 1 over, n is minus 2 here, minus 2 plus 1, x to the minus 2 plus 1, which is minus 1 so over 1, x to the minus 1 plus c, or minus 1 over x plus c. Okay, one last example, and then we move on. Suppose I have 1 over the cubic root of x. Quickly, how do we rewrite that? But we have no choice, we have to rewrite.
First, it's 1 over x to the 1/3.
Repeat.
1 over x to the 1/3.
Yeah, that's the beginning. 1 over x to the 3rd. But we're not done yet because the rule only applied x to the n. Go ahead.
Then x to the negative 1/3.
And x to the minus 1/3 dx. Now we are set. We have to proceed. So this is equal to. So this is my n. This is my n right here. So it's going to be 1 over minus 1/3 plus 1. X to the minus 1/3 plus 1 plus c. Now, of course, nobody likes that. Minus 1/3 plus 1, that's 2/3, which is going to give me 3/2 x to the power 2/3 plus c. And how do you check? Quickly. How do you check your answer is correct? Because we always have to be able to check. What you're finding is the function. When you differentiate it, you get that. So we're going to take the derivative of the answer and find it. If I don't get that, it means what I'm doing is absolutely wrong. So that's going to give me 3/2 times 2/3 x to the power 2/3 minus 1, which is minus 1/3. Now those cancel each other out. I will have that. Okay. Right. Now, property of the indefinite integral. So those are the basic indefinite integrals. Now let us remember the property of the indefinite integral. All right. Properties. First, if I have two functions, like I have x plus square root of x, then we can break up the integral. So the first property of the indefinite integral then is the integral of the sum is sum of the integrals. If I have a sum, I can break up my integral. Second, if I have a constant in terms of a function, like, and this is coincides, sorry, because this is we can do it for derivative. We know integral of this derivative of the sum is sum of the integral. Because we can do it for derivative, we should be able to do it for antiderivative. Again, if k is a constant, and the word constant, as I highlighted in red, is crucial. integral of k times f of x is k times f of x. So we can get the constant out as long as it's a constant. So I cannot take out a variable. What we cannot do, and on your homework, you have to give me examples that tells me that what I'm going to write right now is false. What you cannot do is break a product. Absolutely false. So if I have two functions, I multiply them. You cannot break that because we cannot do it for differentiation. So this is absolute nonsense. So we cannot break the integral if you have a product, only if we have a sum. So let us do two examples to elaborate that. So for example, we're going to evaluate the following integrals. Integral of 3x plus 1 over 2x plus 4 dx. Okay, so let us evaluate this. Now I have a sum, I can break. One over 2x plus 4 dx. Okay, now 3 is a constant. I can take it out. Plus, what can I take out here? 1 over 2x is basically a half times 1 over x. So here I can take a half. 4 is a constant. I can take out my constant. And now we are ready to integrate. So it's going to give me 3, a half x squared plus a half the ln of x plus 4x plus c. Okay, so that's how we're going to do that. Example number 2. Please, if I'm going fast, let me know. But I'm very well aware that I'm reviewing this material, so I'm a bit comfortable. But please ask questions as we move on. Okay, problem number 2. Integral of okay. How do you want me to handle this integral? Simplify the function first. Okay, tell me what you mean by that. First, I cannot break it up because I have a multiplication. Pure and simple. So what do you want me to do? Okay, I read, simplify, distribute. All right, first we have to distribute, crucial. So I need to distribute, but before I distribute, as you guys know from calculus 1, calculus does not like the square root. We have to write using fractional exponent. And now, as your classmate said, distribute. I have no way out but distributing. So this is going to give me x plus x times x to the half. We add the power to the power 3 half dx. And now I am absolutely done because now it's the bare minimum. This is a half x squared. This is 1 over 3 half plus 1 x to the 3 half plus 1. That will be that. I have a sum I was able to find to break it up. And then I will be done because this will give me a half x squared plus 3 half plus 1 is 5 halves, which give me x to the fifth, x to the power 5 halves plus c, and of the problem. Okay. One more along those lines, and then we proceed. So suppose I have the following integral of okay. Ideas? What do you want me to do? I read everything you guys write, or you can unmute yourself and talk, whatever you're comfortable with. You could put the x4 in the numerator. Okay, we can do that. So if I want to put x4 in the numerator, it has to be x to the minus 4 dx. Okay, so far so good. And then what do you want me to do? Remember, I cannot break it up. I mean, I cannot really do anything yet. Then I have this 1 plus x squared. Somebody tell me, open the parentheses. What do you mean? Arian, what do you mean? Open the parentheses. Expand, right. Okay, we expand this. So 1 plus x squared plus 2x, x to the minus 4. So we're really going down to basics. Now I can distribute, and we're done. I will have x to the minus 4 plus x to the minus 2 plus 2x to the minus 3. We are absolutely ready to integrate now. We don't have anything else. This is a sum, so I am safe. This is a sum, I am safe. And now every term. 1 over minus 4 plus 1, x to the minus 4 plus 1, 1 over minus 2 plus 1, x to the minus 2 plus 1, 2 as a constant, I don't worry about it, minus 3 plus 1, x to the minus 3 plus 1. And finally, I just put things together. 1 over minus 3 is minus a third, x to the minus 3 minus x to the minus 1, minus 3 plus 1 is minus 2, and the 2 minus x to the minus 2 plus 3. And then we can definitely check our answer by differentiating this term, and we should get that here. So now let us remind ourselves of all the basic antiderivatives. So now what we saw is the antiderivative of x to the n, but let us remember all the antiderivative so that we're going to be using. So basic antiderivative. First, antiderivative of dx, as I said in class, what they meant here, 1 dx is x plus c. Then we have the power rule, x to the n, and then 1 over x. And now I will ask you the questions and you guys answer quickly. What's the antiderivative of sine x? Quickly. What's
Negative cosine.
negative cosine? Okay. Because if I differentiate minus cosine, I get minus. Derivative of cosine is minus sine, which gives me this sign. Antiderivative of cosine, quickly. That's the sign. All right. Antiderivative of e to the x.
E to the x.
E to the x. Antiderivative of 1 over 1 plus x squared. What is the function? When you differentiate, you get 1 over 1 plus x squared. Inverse tangent. So absolutely, so this is arctangent x plus c, or you can write tangent inverse x plus c, because the derivative of tangent inverse is 1. And this function, we're going to use it a lot, so absolutely memory for that. Now, what's the antiderivative of 1 over the square root of 1 minus x squared? Do you guys remember? That's the inverse sign. Absolutely. Now, what's the antiderivative of secant squared? It's the function. When we differentiate, you get secant squared.
Tangent.
Tangent. Absolutely correct. You guys have to remind yourself because we're differentiating this. We're anti-differentiating. And finally, the antiderivative of secant tangent. That's secant. Okay, so those are the basic antiderivative. And believe me, these are the only ones that you have to memorize. There is only one more that eventually, when time comes, we will memorize it. Otherwise, these are the only basic antiderivatives that we need to memorize for the course and forever. So you won't need to memorize anything else. There is only one. But I'm going to add a square here at some point and do it. All right. So now let me ask you the following question. Question. So integral of 2 sine x cosine x. Okay, so questions. All right. Two students evaluated this integral. Joe gave me the following. The antiderivative is sine square x plus c. Okay. Now Peter evaluated this integral, and Peter gave me 2 sine x cosine x dx, and Peter told me it's minus cosine square x plus c. Okay. Can both Joe and Peter be correct? Justify your answer. Okay, I give you a minute to think about it, and I want answer. I want two different, actually, I want two different reasons. Whoever is ready, just let me know. Just speak up. Right, anybody is ready? Luke, tell me Joe is correct. Okay. Luke, because you can unmute and tell me why it is. He's correct. Ah, you didn't check Peter yet. Okay. All right, check Peter. Anybody else? I differentiate Joe's right-hand answer and got the left-hand side. All right, so let us see. Joe is correct because, all right, we took sine square and we differentiated. Okay, what's the derivative of sine square? All right, let us remember that sine square is sine x to the power 2, the derivative. Now the chain rule tells me, so this is my inside function. It's 2 times sine x times the derivative of the inside, which is cosine. So absolutely, Joe, correct. Now, okay, Abuka tells me Peter is correct. Let's see Peter. Okay, so I'm gonna take the right side and differentiate it. If I get 2 sine x, it means we're fine. Cosine square x, it means cosine x squared. I need to differentiate that. Right. So cosine x, the chain rule tells me that's 2 times cosine x times the derivative of cosine, which is minus sine. So this is 2 cosine x sine x. So both Joe and Peter are correct. So absolutely they are both correct because we differentiated both of them. We got what's inside the integral. Now, so they are both correct. Now, can anybody give me another reasoning for it? So absolutely correct. They are both true. Can you think of another reason why both of them are correct? What you guys gave me is perfect. Who can think of another reason?
Is it like sine squared x and negative cosine squared x are like the same graph? Or am I misremembering?
No, you're not. You're not. You're not. You're not. No, it's absolutely correct. Let us remember the other reason. We know the relationship between sine and cosine, correct? So we know that sine squared x plus cosine squared x equal to 1, right? The most famous trigonometric formula. So it means that sine squared is nothing more than minus cosine squared plus 1. Are you with me? So sine squared and minus cosine squared are actually the same function. They differ only by a constant. Since they both differ only by a constant, so they can be the same, the both answers can be absolutely correct. So if this one is correct, this will be automatically correct because the difference between those and 2 is only a constant. All right, so this is correct by differentiation. This is correct. You can either by differentiation, or you can say because minus cosine squared x is nothing more than sine squared x. Let's see, minus cosine nothing more than sine squared x minus 1. So they are practically the same function. All right. Okay, that's it for today. For tomorrow, your homework is on bright space. The homework is, I have a bunch of derivative functions that you have to differentiate. Please make sure you do them because you have to know how to differentiate. And there are a bunch of problems which are how to integrate basic integral. And yes, the answer is yes for Jonah. I think, yeah. And so make sure you do all the homework for tomorrow, and you have any questions, you tell me tomorrow. Okay. All right. Any other question before I let go?
Hi, Professor. I was wondering, is it possible we could like hook up your Zoom to the projector in the class?
You can
We
do
were like thinking about that.
anything that helps you.
All right, cool. Thank
Anything
you.
that's good for you guys will be accepted. Any other question?
Will we be able to watch the lecture over again?
Yeah, I'm recording it, so I'm gonna do my best to put the lecture on bright space once I'm done.
Okay, thank you.
Okay, I hope it will work. Any other questions? Okay, thanks a lot, guys, and see you tomorrow. Make sure to do the homework.
Bye, Professor Elias. Have a good
Bye-bye.
day.
Thanks a lot,
Thank you,
guys. Bye.
Professor.